Okay, guys, so we are now at number 6, the CSEC Math, January 2024, paper 2, with a solution. All right, so this question now tells us that pi, take pi as 22/7. So we're gonna be doing some circular measures. And it says the diagram below shows a hemispherical bowl that's half of a sphere. Hemisphere is half of a sphere, and a cylindrical tin. That's a cylindrical tin. It says the diameter of the cylindrical tin is 12 centimeters, and we tend to work circular measure with radius. So I'm going to indicate right away that the radius of this tin is 12, is half of the 12, which is 6. I'm going to write that right here, so don't forget. So the radius of the cylinder is 6 centimeters, and I'm saying cylinder because there are two objects we're going to be using radius. All right, so I'm going to identify them separately. The radius of the cylinder. That's why I write R, guys. Can I write R any better? That's just how Mr. Shaw writes his R's. All right, and this now R is the radius of this hemispherical bowl. All right, so when I'm working, the radius of cylinder is 6, so don't use a 12. It says the height is 17 centimeters. And first part wants us to show that the volume of the cylindrical tin is 1926, correct to 4 significant figures. So the volume of a cylinder is pi r squared h, which is the area of the base, which is pi r squared, times the height. So the volume of the cylinder would be pi r squared h. This r is the radius of the cylinder, so I'm putting the c on it. The h is the height. This is the cross-sectional area of the base, and this is the height right here. So we're going to drop the values in there. The pi is 22/7. The radius, as we said, was 6. We're going to put 6 squared, and then the height is 17. 17, and this should give us this value. Let's put it in calculator over here. So it's 22/7 times this 6 squared is just 36 times 36 times, that's 17 height. 17, see? Correct the 4 figures, it's 1923 centimeters cubed. And that was shown. Did ask us to show it? That's the same figure we have here. All right. Next part says the bowl is completely filled with soup. When all of the soup is poured into the empty cylindrical tin, 90% of the volume of tin is filled. So it's 90% of this. Calculate the radius of the bowl. So basically it means that the volume of the bowl is 90% of the volume of the tin. So we can write that. All right, the volume of the bowl. The volume of the bowl becomes 90% times the volume of the tin of the cylinder. All right, 90% of the volume of the cylinder. And we can actually work that out. 90% and the volume of the cylinder. And we can work that out. The volume of the cylinder is this one. We're going to work that figure right now. So 90% is 0.9 times that 1923, and we're getting 1730.7 cm cubed. That's the volume of the bowl. All right. The question is asking us for the radius of the bowl. So we have to use that information that we have. Because what is the volume of the bowl? Now, the bowl is a hemisphere. They have given us the formula of the volume of a sphere. That's a full sphere. So a hemisphere is half of this. Hemisphere is half of a sphere. So the volume of a hemisphere, let's call it H for hemisphere, which is a bowl, is half the volume of a sphere. And that's why the volume of the bowl, which is a hemisphere, is half the volume of a sphere. And the volume of a sphere is this one. So we're taking half of that. So half of this number basically turns this 4 into a 2. So it becomes 2/3 pi r cubed. So this is the expression now for the volume of the bowl. Let's put that in red. And that's what we're going to be using here. We're going to equate this volume of the bowl now to that number and calculate for the R. So we're going to put 2/3 pi r cubed on the bowl is equal to this, which is 1730.7. And we're trying to find the R. We don't have a lot of space to work with, and that's a problem with these things. So we don't transpose and make R the subject and do one calculation. So watch me now. I'm going to take this 3 and multiply it up here first. And then I'm going to divide by this 2 and this pi, divide it under there. And then afterwards, I'm going to take the cube root. So I'm going to show this step by step in this video, but let's write one expression at the end. All right, so let's shift this over a bit. First, I'm going to take this 3. I'm going to multiply it up here. It becomes 3 times. All right, 3 times. So let's do that. So this expression is going to move. So write the next line first and leave that first and write it as the next line. So let me make it a little bit smaller. They don't give a lot of space to work with, guys. They just don't. So let me copy it just to show the transposition will go. Because afterwards, write one expression. They don't give a lot of space to work with. All right, so let me show the transposition now. I'm going to take this 3, as I said, this 3, and multiply it up here. All right, so I'm going to multiply that 3. So I'm going to move it right now and multiply this whole expression by that 3 to show what the final result is going to be. So it's going to come 3 times that. 3 times that. Then I'm going to divide by the 2 and the pi. So I'm taking the 2 pi and put it under here. So I'm going to divide by the 2 and the pi. So divide by the 2 pi. And the 2 pi will be gone. Just erase those. And then now, this is r cubed. And if I want r, then I will have to take the square root, the cube root, sorry, of both sides. All right, and then this cube root will eliminate that cube. And I'm going to be left with this r, so I can erase that. And the r is going to be equal to that cube root expression there. All right, so I can leave the cube. Oh, let me take out the cube. So the r is just going to be equal to that. So that's what I'm going to put in my calculator to get the answer. Let's just write this a little bit better. So the r is going to be equal to the cube root. So let's change this. All right, that's a cube root. So I hope you saw that transposition is a cube root. I'm going to put this in the calculator and get one answer. So it's going to be a cube root of a fraction, and that fraction is 3 times 1730.7 divided by 2, and they did tell us to use the pi as 22/7. So I'm going to put that there, that bracket 22/7, 22/7 in the place of the pi. So I've changed this, written this pi as 22/7 in the calculator. All right, I'm gonna leave that in red, so we'll see what we did. And then I get the answer. I'm gonna write 3 significant figures, 9.38 centimeters. Remember, it's a radius, centimeters. All right, and that's what we have here for the R. All right, that's the R right there. Okay, that is it. Yeah, that's it. We can double check it. Let's make sure. We can double check it by calculating the volume again right here. So if we have to calculate the volume again to get this, just to double check the value that we have, it will be 2/3 times pi, which is 22/7, times that radius cube, right? That is 9.38 cubed. And we get the same value with almost, as we're not using the exact value for the R that we got, right? Which is good. All right, so we can accept that answer. Very good. So let's continue down here. This question says a simple trigonometry, like it has some circular measures in it as well. It says in the diagram below, L, M, and N are on the circumference of a semicircle. That's a semicircle. So it means that this is the center, right? That's what it said, center O. And the radius is 18. So this side is 18. So they've given us the radius. Let's put that on the diagram. So remember, every line from the center to the circumference is a radius. So this is 18 centimeters right here. This is also 18 centimeters. So the diameter is 36. This is also a radius, 18 centimeters. All right, that's what we have. This is a 90-degree angle, as you can see. All right, and let's see what this says. It says calculate the total area shaded. Wow, all right. So the total area shaded is the area of the semicircle minus the area of this triangular space in there. Simple as that. So the area shaded is the area of the semicircle minus the area of that unshaded triangle. Let's write it. So the area shaded equals area of the semicircle. Let's put S circle, meaning semicircle, minus area of that triangle in there. That's it. Now the area of a circle is pi r squared, so a semicircle is half pi times the radius squared, r squared, which becomes 18 squared. And you're subtracting the area of that triangle, which is half base times height. Now the base is 36, half of the base is 18. So half the base, which is 36, 18 and 18 is 36, times the height of the triangle is still 18. All right, so the base of the triangle is 36, and write that. So I want to write that Ln is 36 up here, which is the base. So we'll see, we'll get this 36, right? And then we'll just put this in the calculator. All right, this is a half pi r squared formula because area of a circle is pi r squared, so the hemisphere is half, the semicircle is half pi r squared. So this is the pi r squared, half pi r squared, this thing. And that's what we're using here. So let's calculate one calculation with all of that. And that should give us our answer right there. I'm going to use 22 over 7 again. Did they say that for this whole question? Yes, it's for the entire question, right? All right, so let's do that down here. So it's going to be half, the same as 0.5 times a fraction, 22 over 7 times 18 squared. And then I'm subtracting another half. Well, half of this 36 is 18, so I'm subtracting another 18 squared. But this is 18 times 18, 18 squared. And I'm getting 185. 185. That's three significant figures. Centimeters squared. That's it. 0.5 minus, this is half of 36, which is 18. Let's double checking, guys. All right, that is it. All right, easy. 4 marks for doing that. This is the same question. Oh, just a repeat of the page. Page 19, okay. Oh, that finishes this question. Wow, question is done. So That ends number 6, and we'll do number 7 in the next video. So number 7 will start with this pattern question, sequence and pattern. All right. So let's stop this one and we'll start the next one.